long to work on each task before switching to a new task and what that new task is. And what you tend to find is computers do this so fluidly between the various responsibilities that we give them. It looks like they are doing their responsibilities simultaneously. But of course, we all know what happens when things go wrong. Your computer crashes. And what I want to do in today's lesson is take one principle related to the computer science of scheduling to help give us some idea about our own human struggles with time. And what I actually want to look into is the fact that many of us fail to realize the more time you spend prioritizing your work is actually time you are not doing it. So for example, let's just say you check your inbox and you plan to prioritize different emails. Seems sensible, right? You will take your high priority emails, you'll put them in a high priority section, and so on and so forth. However, there's actually a problem with this, and it's commonly referred to in computer science or mathematics as a quadratic time algorithm. Let me explain to you what that means. So if, for example, on a Monday you have an inbox of 10 emails, it will take you 10 minutes to sort this out in priority. If on Tuesday you have 20, Wednesday you have 30, 40, 50, and so on, you now can understand that the time taken will multiply by 2x, 3x, 4x. So it will take twice as long, 3 times as long. And the reason why I'm addressing this is because the programmers in Linux encountered a similar problem. So what the programmers used to do is rank every single task in the order of importance. And what they actually found is that they spent more time ranking their tasks than doing them. So what do they go ahead and do is they basically said that they're gonna limit the number of priority buckets they have, which generally meant that they were less precise about what to do next. And what they realized is they actually became more efficient by spending more time making progress on the actual tasks themselves. So let's go back to our email analogy. If you insist on doing the important things first always, it may not necessarily be a time efficient activity. Because you're prioritizing in such a manner, the quadratic time algorithm tells us that eventually you will get to a point where your high priority emails, there'll just be so many of them, you're actually better off replying to those emails in chronological order or even at random. So the takeaway for this lesson is, surprisingly, sometimes giving up on doing things in the perfect order could actually be the key in getting those activities completed.